We are reconvening with the MEHF session. Before we get started, Maria, are you gonna chair this?
I can do it if you wish. Let me know. I don't know if it's easier for you to do it from there. Otherwise, I can do it online. Let me know what you prefer.
I'll try, but I would just need someone to read to me. So first we have David.
Yeah.
So why don't you start with that one?
Maybe I can, if you wish, I can make a short introduction maybe to the group. And
why don't you give the introduction and then David can take it.
Perfect, thank you. Yeah, so a very short introduction to the group. So this is a relatively new group. The topic is multimedia experience and human factors. This was established as a kind of spin-off for the HFVE group. With the idea to collect in this group all the presentation and the work and the activities on this topic. So in the first year, we have mainly focused on understanding what are the interests within VQEG in this topic, and had a few sessions, 2 sessions, last conference, last event, last meeting, and this one. And now the idea is also to start more focusing on specific activities if possible. So we would like, together with Mikolai, who is chairing this group, and I'm helping him in this first year or so, to collect the interest from the group in terms of first of all, interest in participating in the group. And then if there are some specific topics or challenges that the group would like to address, we would be happy to establish some work items on this topic. So for today's sessions, we have 4 presentations. And the first one is this one from David Juska on the impact of valence and arousal of video content on subjective quality of experience assessment scores. And he's going to present the preliminary results of the study. Please, David.
Thank you very much. I think it works. This is the experiment that I'd made with my master of the student who is preparing a master thesis, and last year I was in Milan, and during the meeting with people from there, I found that there is a very nice video database with annotated parameters, valence and arousal. It's for each frame continuously annotated by a very large number of annotators, relatively large number. It was 192 people who did it, and I thought that it would be nice to try to do some, let's say a small experiment, very briefly prepared, and this is what is the effect of this experiment. So first, I'd like to say something about the research background. I will try to state the problem here. Then theoretical framework and methodology, preliminary findings and conclusion. Key research question was how do emotional dimensions of video content affect quality of experience ratings? There are some works on this topic, but not done on this database. So I give it a try. A background for methodological background to operationalize these emotional dimensions is Russell's circumplex model of affects, valence arousal framework. And in order to represent the emotional states of humans, numerous studies in psychology and neuroscience have proposed methods to quantify humans' emotional state, which include both categorical and continuous models of emotion. The most famous and dominant categorical theory of emotion is the theory of basic emotions, which states that certain emotions are universally recognized across cultures, like anger, fear, happiness, etc. And that all emotions differ in their behavioral and psychological response, their appraisal and in expression. So alternatively, the model used in this experiment, the circumplex model of affect, a continuous model of emotion, proposes that all affective states arise from two neuropsychological systems related to valence and arousal, and all emotions can be described by a linear combination of these two dimensions. And valence indicates whether an emotion is negative or positive, and arousal indicates the intensity of an emotion. And here is the graphical representation of the circumplex model of affect with the horizontal axis representing the valence dimension and the vertical axis representing the arousal or activation dimension. You can see here, yeah, like maybe better not to use the laser here. You can see this in this wheel that all these emotions can be represented by those two dimensions. Okay, and methodology for this experiment was, let's say, a classical crowdsourcing experiment. We decided to use 4 levels of bitrate to formulate PVSs for each source sequences. The duration of experiment per subject took about 10 minutes, so it's very convenient for crowdsourcing. And we made it very budgetary. So link to the experiment was distributed in social media. We have a fan page where people who, let's say, are interested in our research can follow, and they took part in experiment. And also we found some still naive family and friends. No remuneration for participation here, and finally we get results from scores from 28 people, and gender distribution: 14 men, 11 women, and those who don't define themselves, 3 people. Methodology was also focused on video content selection, because this database, VQEG, video-based emotion and affect tracking in context database, the link is there. It consists of 124 video clips from Hollywood movies, documentaries, and home videos, also taken from, for example, YouTube. And in this database, we have continuous valence and arousal ratings of each frame via real-time annotation. And from this database, we took 8 source sequences originating from movies. There was the first criterion, and then selection criteria. I tried to describe them here, but maybe later on I will describe them in more detail. So clear differences in arousal and valence parameters between clips, possible stable level of parameters through about 15 seconds of clip, considering also scene cuts. So these sequences included or in this database are, say, differ in terms of duration. So we decided to cut fragments of them to make them suitable for our experiments. And of course, we based on this continuous annotation. So we believe that it is not very evaluating the whole context situation of those sequences. So we finally we built two groups of clips. We call them high arousal, high valence. This is this red part of the framework. Left, sorry, mine left, but yours right upper part. And the second group was low arousal and low valence. Maybe I will leave this stage for questions later on. And we, according to the graphs that we prepared for each sequence from the database, not only those 8, but all sequences, we found out that there can be, let's say, distinguished threshold levels of arousal and valence to group them as high arousal. Its parameter is 0.28, arousal low minus 0.21, and valence high 0.39, and valence low minus 0.17. And yes, and here is a presentation of example of sequence. It's 122, and you can see that how this arousal is red, valence is blue. You can find how it looks across all frames of the sequence 122. And the yellow part is the part we distinguish, we cut as a clip for our SRC sequence to our experiment. And this is example of high arousal, high valence. So through all these parts that we selected for the experiment, both of these parameters are relatively high. And here is an example of sequence number 5, source sequence, and here you can see that there is low arousal and low valence level. And selected this sequence was source sequence is marked here as in yellow color. Of course, we didn't do it, let's say, blindly. We checked the scene cut and to make those sequences look nice and acceptable. Here are exemplary frames of this sequence. First is concert situation. The second one is Robin. I forgot the name of the actor. But here is a situation in the hospital, and this guy is trying to cheer children who are there. Third situation is in the aeroplane where the nice food is served, and the fourth situation is the meeting of lovers. And these 4 sequences have high arousal and high valence. And those are representatives of low arousal and low valence. There is a kind of chat between two people in the first video. Second sequence presents also a chat, but in more formal situation. I believe that it's kind of a attorney here and a couple. Third one is a woman who is preparing kind of decoration, and it seems that she is quite sad. And the third situation is also situation in hospital, but they are, say, talking with a grandfather who is lying on bed. And because these source sequences, as you can see, they are originating from different kinds of movies, and The problem with this this experiment was to get the best possible quality of this source material, and it was very tough task. But we made what we could to get this. And here are presented how we try to select bitrate levels, because for each sequence we couldn't assume that the bitrate level will be will be the same for each source material, because source material differs. And we decided to run VMAF to draw this graph here, those graphs here, and on the basis of those graphs, we tried to find for each sequence, we tried to find levels that will be representing the say MOS scale for our experiment and for our sequences. And I will not present all this stuff because it's not very interesting, I think, but the results here, very preliminary, we decided to analyze in a specific way. First, we have to compare groups. So we built two groups, high arousal, high valence, as you heard previously, and low arousal, low valence. We decided to use source sequences as one of bitrate level, and here you can see 4 levels. And characteristic of collected data, samples are independent, can be non-equinumerous, samples can be small. Measurements must be performed on a 5-point Likert scale, which with all consequences of being ordinal. Method should show which sample gets higher scores and should estimate how different these samples are. So we used non-parametrical methods. They are, I proposed them in my PhD, and I decided to use them also here. Test for stochastic dominance and test for shift of mean value. And the results here, you can see that difference between it's quite interesting that those sequences which were representing low levels of arousal and valence got higher results. Differences are not very, let's say, big, but I think that future research could be more detailed, better, let's say, we could use better source material in better quality to use in this research. And of course, I see the room to improvement to make those results better more accurate. So this is the results for VATIC. Of course, selected sequences from VATIC database, and that's all what I prepared for today. Thank you.
Thank you, David. Any questions from the group?
Could you explain the last slide a little bit more? I don't understand what the 0.4, 0.15, and 0.06 stand for. What is E of L minus E of H? What questions did you ask for the ACR scale?
The questions for the ACR scale was what is the how you it was in Polish, how you assess the quality of presented material, yes, presented sequence.
Okay, so perceived quality.
Yeah.
Yeah. Okay.
Classic ACR, yes.
Yeah. Okay. Do you think it would make sense to run a GLM on this to find out the different factors more detail, like for low and high?
I think that because this is, let's say, just to check how the this data will work, I think that we need more experiments on this and prepare them with better source material. Because here I did this experiment with the, let's say, caution that we are using the material which is in database provided by people who prepare this database, but we need to, I think, prepare our own source material, and these results will change, I think. But the kind of, maybe not tendency, but something from these results tell me by intuition that we need to that there is the room to improvement and to find results more stable. But of course, I will try to do GLM analysis.
Thank you. I saw 3 hands. We have Maria online. I saw Naim and I saw Patrick. I don't remember who raised their hands first. Naim.
All right. Okay. Thank you very much, David. Actually, it's a very interesting one. The thing I would like to be, have you checked temporal and spatial information of high arousal and high valence sequences as compared to low arousal and low valence sequence as well? What type of temporal,
you mean objective
spatial
metrics? Yeah.
Yes.
Temporal,
Yeah.
I didn't do it. Yeah. For this experiment, because I was quite sure that the database didn't offer a very good quality of source material, so I took those sequences that represent the best quality I could get as a source material. That's why I didn't do this analysis. But for sure,
actually, this is another. It's a very good dimension to check that one, because if you have a strong emotions, right, that's mean there is a more spatial activity and temporal activity over there, right? So this is the one. So that's mean we are our previous, the temporal spatial activity is more than, that's mean you need a more bits to be encode the video. So this is a one thing. And then also, have you tried to be also to make a comparison between high arousal and low valence and the other, just not going only on high and high, but go in a diagonal as well and see that one, how it is behaving as well?
Yes, this is my idea for future work, because I tried, as you can see, to limit the scope of this experiment just to those 2 quarters. Yes, but for sure it would be good idea to also offer those quarters and then do comparisons in these ways. But of course, I need to do this research. Coming back to metrics that you are asking for, I also I didn't do this because I think I covered it by preparing these graphs here using VMAF to select the let's say propose the bitrate levels, because I think it quite works. It works quite good.
I saw Maria lowering her hand.
Yes, I lowered the hand because my question was answered, actually.
Thank you. And I know, Patrick, but allow me, since you have that, I have a quick question on this one. Did you pick the bitrate to hit a certain VMAF target? How did you pick the bitrate?
Okay, so here is what VMAF suggests.
I know.
But then I, let's say, empirically verified the levels, because the VMAF, you know that it covers HD resolution here at the basic level. Here, not all of these sequences had this resolution. So, for example, what we if I have chosen, for example, because we map VMAF to MOS ratings. So if I took, for example, it was 2030, it was the quality of image when you of video I checked, it was horrible. So I tried to, let's say, move around here. Yes.
My only question is, say you called it bitrate 1, right? So
Yeah.
there is a source. Did the VMAF quality, was it matching across all of your sources?
No.
So going back to what also again Naim suggested, my suggestion would be, the way I would choose it, I would pick 4, call them quality targets. Forget about bitrate for the moment. Right?
Okay.
There is no bitrate. There is only quality, which is obtained through that one. And we can talk about the difference in resolution. And I would say I'm going to pick 80, 60, 40. I'm just naming 3 numbers.
Mhm.
The most important is that the encodes you pick for the different stimuli, the different sources, would match. Yeah, it may be 81 versus 79, but by matching the quality as predicted by an objective score, you remove out of the equation which is a very easy thing to think about, right? Something that has low valence, low arousal, probably something low, slowly moving, which means that you tend to get higher quality at the same bitrate. So I'm not sure exactly how you chose, which ones you chose, but if you want to repeat the experiment, I would start by picking constant quality encodes across different sources. And then I would do the comparison to eliminate external factors other than the 2 you are trying to investigate. That was my point, but it's Patrick's turn.
It's a classical way that it should be done. Yeah.
So I will extend a bit the question that has been asked by Naim. But just for clarification, when you say low valence, what are we talking about? Because valence is negative or positive. So when we say low valence here, are we talking about neutral thing? Or negative?
Negative, because neutral is here.
Okay, so it's it's really negative.
Yeah,
Okay.
negative, yes.
It was also my question, Patrick. I think you shown that when you shown the plot with the circle, it was somehow there. That's why I thought my question was answered. Maybe you go back to the circle that you have shown before.
Because it's
this one
very,
here.
Yeah.
So
it's
he
very,
had pleasant here. So I assume pleasant you meant high for you and pleasant meant low. Is it the case? Because the balance is a positive or negative experience.
Yeah,
but you cannot separate them. Yeah.
What?
You cannot separate valence and arousal. They are measured.
No, we just want to be sure that when you say low valence, it's a negative.
Yeah, low valence.
Okay.
Low arousal.
Yeah.
So we are operating in.
No, but I'm surprised because it's very difficult actually to find some stimuli which are both low arousal and low valence, because usually you have some kind of if you plot in a 2D plot valence and arousal, most of the stimuli you will have it's very well known that you have a kind of curve like that. It's difficult to find, let's say, neutral contents, let's say 0 valence that trigger high arousal, and similarly usually negative valence will go with higher activation arousal, and similar high positive valence will go with higher positive arousal, positive higher arousal. And by the way, even in this shape, when you look in in 2D plot arousal versus valence, usually with negative valence, you can go much higher in terms of arousal than with positive stimuli. So this is why I was a bit surprised. How can you find a low arousal and low valence stuff stimuli?
I was operating on those data that was collected in Beatic, and when I draw them plot them in this graph, you can see that here is situation where is arousal and valence around 0, and they operate like this.
Is it possible that you kind of remove the sign in valence somehow?
Yeah.
Is it? Can you repeat? Is it possible?
Maybe somehow you remove
valence?
the sign in balance, because balance is you have a very positive emotion, very negative emotion. but here it seems to be related just to high emotion. So maybe it seems that you can remove the sign in the balance.
That I cannot remove sign from the
No,
balance?
did you, the question of Maria is that eventually did you took the absolute value of the
No.
balance?
No.
No. So you took the.
Sorry if I'm interrupting. I noticed that we have budgeted 15 minutes and we are
Okay.
almost.
No, but, so one
if-
thing I would strongly suggest is to take this database that I don't know, but to plot this, to generate this 2D plot, arousal versus valence.
Okay.
Yeah.
Okay.
And see if you observe the usual shape that has been well reported in psychology studies of arousal valence, because maybe there is something, you know, we can suspect that the data we are relying on are.
That's so convenient.
Yeah.
Okay.
I will strongly recommend to do this sanity check. Yeah.
Also available. So there is a lot of databases available. They already provided this with the crowdsourcing, with the valence and arousal values. So maybe I think so. Yes, not continuous. Yeah, definitely.
Yeah, that's why I wanted to present. Yeah.
To secure if they have similar trends that is expected from other psychology studies.
Okay. Thank you very much.
Okay, let's
Okay,
go
so
to our
now-
next. Go ahead, Maria.
Yeah.
Anna.
So yeah, just I think I just present the presenters, so you go ahead with the questions then. So the next presentation is online and it's given by Syed Buddin. I hope you are well enough to present, Syed. We're not feeling well.
It's fine. I will try to.
Okay,
I'm
perfect.
fine. Yeah.
And his presentation is on subjective evaluation of HAS and low latency algorithms for enhanced QoE.
I want to share screen.
I think we need to stop sharing from our side. Maybe wait a moment.
Yes.
Try now, Sid.
I think it's here. Share. It's fine. Can you see the slide?
Yes.
Okay. Set, right? Should I start?
Please do.
Okay. So, hello, good morning all. This is the part of my research work. Basically, my domain is adaptive streaming and measuring the quality, video quality in adaptive streaming environment. This is one part of the work which I going to present here. I will give a background to the adaptive streaming networks, how it works. Basically, we have video stream on one end in which we encode it in having different representations like quality levels, good quality, bad quality, average quality. And then we have a like server, streaming server, web server, which we migrate all those representation. And then the end client from the end side, they access that web stream, streaming server through ABR algorithms and access that content based on their network capability. Here is another scenario. For example, I have one video content encoded at two different bit rates, basically, with a low and high. And then I like store it on a streaming server, and then client requests based on its network capability and go for which content to be downloaded on its end. I hypothesize this part of work. Basically, when we have a streaming scenario and there is abrupt changes in bandwidth profiles, if bandwidth is going low or going high, so we have like different scenario. For example, interruption. We have stalling events. We have switching quality switching among the content. And my task is, or my objective is over here, how to, I want to measure how that styling or quality switches or segmentation impact on the optimize ABR algorithm and the user perception, user quality of experience. So this is a hypothesis. This piece. Now we have ABR algorithms. I look at it like we have three domains or classes. One is bandwidth based ABR algorithm, buffer based, and then we have recently developed the new innovative algorithm, which is low latency or ultra low latency based algorithm. So that I opt initially in my experiment, this 4 or 5 algorithms, and I make it, I look at like the Hayes traditional algorithms and low latency algorithms. So this is one part to differentiate or to compare the different mobility scenario among those Hayes and low latency algorithm, and then we see how it fluctuates the video quality. So here we can see when I have this sort of work, like in a streaming domain, go for opt for some network profile. So here I opt for very low bandwidth rate. Like for example, this is 1 Mbit. So I went through even tested 500K, 600K bit. Then I have that I keep constant. Then I increase the bit rate to like 4 Mbit. So I encoded sequences with 4 Mbit, which is maximum. Then I fluctuate. I need to shape the network with passing 1 Mbit and then maximizing it, passing the segments into 4 Mbit, which is the maximum. And then I have another scenario where I tested the segments, the content, on starting with the maximum bandwidth and going through lower bandwidth. And the data set that is mostly based on 1 MPEG dash data set developed by University of Klagenfurt, a Christian Trimmer research group. The source was like raw YUV format, 1080p, which is full HD, and the codec it is AVC, MPEG AVC. I opt like for my experiment in this scenario, I opt for 30 segments. Each segment, which is the minimum duration of segment, like 2 seconds, that is the lowest one. And so it means I have 1 minute. I tested a 1 minute, a 60-second long video. So we have encoding later here. So I have the representation of having the higher resolution and the lower resolution, medium resolution, so that we can opt, like you can see here, I tested mobility scenario with 918 or 900 kbps, and then I have here with a maximum 4 Mbit, which is like maximum in my bandwidth profile. This is one. For evaluation, I use dash.js, which is a reference client, and I like have a client server scenario deployed using dash.js, and that is basically a playback for MPEG, and it's industry standard as well. They have a JavaScript embedded. So that is the evaluation network. Here you can see the bandwidth profile. So here I have a smooth transition starting from lower bandwidth rate, and then it is smoothly switching to like 2, and then and then 4 it is constant. This is one scenario, and then I have another scenario which is abrupt. I put it. Got one experiment which is I started with the maximum. I utilized maximum bandwidth of the network, 8 Mbit, and then I drastically drop it to 500, 600K. That's, the lowest one. And then I, stream some up segments, and then I abruptly spike to the 8 Mbit. And then this is the second scenario. Over here, you have, you can see it's like I start from 1 Mbit, and then, I need to spike, and then for 4 Mbit, the rest of segment I stream. So those are the bandwidth profile which I utilize in my test scenario. So now, basically, when I run that like streaming scenarios, so now I know about the bit rate of the all downloaded segment. For example, one person, he has the full capacity of network, and he has the maximum quality level downloaded, so I can exactly see the bit rate of that downloaded segment. And then I can also measure that how many bit rate changes were there. So that is like the quality level. Is that abrupt, or it is smoothly changing? And then I have average bit rate change, and I can calculate average bit rate. So that is basically the metric which I use. Here I have an example from my work. Like, for example, the segment 1, it is streamed using 100 kbps, segment 2, segment 3, so I have 30 segments. Then I can look for observation. For example, I can calculate the average bit rate in one streaming scenario. Then I can have I can observe the quality level switching, and I can see like the abrupt changes, maybe like from maximum quality dropping to lower quality, or from lower quality going to maximum quality. That is, the bit rate changes. So in metric, I have exactly the bit rate for each segment, number of bit rate switches, and rebuffering event if it's stall. So in how long it is the stalling occur, how many seconds, or how many times. So those are all the data which is required for my metric. Here are some preliminary results which I gauged, and I think it is. You can see on the left side it is Hayes algorithm, traditional Hayes algorithm, and on the right side I put low latency algorithm. So I can see the bit rate, how it like I can exactly see or estimate what algorithm achieve the high bit rate, which is corresponded to its quality level as well, and which one has the lowest, or which content, or this is the one observation. And this is for network profile 1. So I have 4 profile, and this is these are all the observation. From this scenario, I can have like the number of switches, which algorithm was prone to switches in a specific mobility scenario, abrupt changes. So here you can see the like LOL plus, which is low latency algorithm. It gave the low number of switches and like the smooth playback streaming. So those are all observation I can make from here. Here is another scenario, which is network profile 2. And then I can see here the Hayes dynamic Hayes algorithm. It has like the highest bit rate, maybe following with LOL plus, low latency. So this is these are all the analysis. I need to see like which specific algorithm in a specific environment, in specific mobility condition, it give me yield high bit rate or low bit rate, or what is the reason, or how it basically what is the trade-off between those switching and video quality. That is one other observation from my metric. And here I can see like in this scenario in network profile 2, I have the LOL plus. It has the lower number of switches again, so it give me like the smooth playback streaming. Again, if I like look for the frequency and duration of rebuffering events in each scenario, in the network profile too. So here you can see, basically this is the low latency algorithm. It has less duration of rebuffering event and less number of rebuffering occurrence as well. So this, and if I can see here, the haze, traditional haze, it has, in this scenario, it has the longest number of switches, and it means buffering happen maximum time in this scenario. So the input from it is basically the objective evaluation from the first part. The input from there that I need to find the optimum, like optimize the strategy, ABBR strategy, and then see which specific case scenario or mobility scenario fit to a specific algorithm of specific class. This is one thing, but I need to confirm it with like subjective evaluation. So for that, now I have the stream processed, we call it process video or stream sequences, which they exactly, it is after the streaming scenario. So it is already started now. And then I need to launch it for the end user or end client, and I need to ask their opinion, and maybe it give me like a kind of correlation or how much the quality is deteriorated in that streaming scenario. So that is another like acceptance or validation of these mobility scenarios. So now I have 24 PVSs for my subjective evaluation. In this 16 are processed video, 4 video sequences I use with the high quality in like original source quality, and 4 were with the low quality. So combined, I can say it is 24 PVSs used in subjective evaluation, and each video sequence was 60 seconds long, which was the similar. So I need to like keep the parameter static for subjective evaluation, not to change anything in terms of timing segments. So basically I use ACR in absolute category rating. So we need to like show, okay, the subjective evaluation, it happened in the crowdsource platform, Prolific. This is one like part of the work that we need to gather maximum opinion and do it like globally. So we need to deploy a Prolific environment for my subjective evaluation. And then we have a Likert scale, like 5 rating, which is normal, the traditional classical way of measuring the opinion, starting from low quality and going to high quality or original quality, 1 through 5. And then we have, mean opinion score, MOSs from here. So again, the content, as I mentioned, that is the similar, which, I obtained from my streaming or mobility scenarios, distorted one. So I need to keep that static. And that was 60 second long and full HD, 24 frame per second. So basically I use VBR encoding, which we put like maximum, minimum, so ensure like the buffering parameter and how much minimum bitrate it will yield, or how much maximums we need to think. The test participant is, I mentioned, it is a crowd source, this experiment is happen in crowdsource platform Prolific. So we open that poll and we gather the test participants. This 25 I mentioned here, that is the valid result which applying. So that was a challenging task. Like 2 of my colleagues, which they were involved to include this inclusion exclusion criteria. So we need to stick with like 0.75% correlation, which is ITU are recommended. So that was like holding, and we were not happy to have something minimum like 0.4, 0.5, which is also acceptable, like a weak correlation, but we stick with 0.75, and it gave us 25 valid results among like 70 test participants. So the rest was discarded, and there was different reasons, different region where we have discarded the test participants. So that is the valid 25 results. And here, it started with this preliminary evaluation, looking into the results, and then it was in my mind to see, like, for example, I need to have a comparison how the people they provide opinion to the Hayes encoded version sequence, and then the low latency video sequences. So this is one comparison I can make, which algorithm perform better, which is slightly, so I can see here with each content in each like sources with the mean opinion score, and then I can draw some conclusion here. And here I provide like this correlation analysis where we can found the weak and strong and medium level correlation. We can have we can know about the consistency of regarding the opinion from the test participants. So that is one observation. I just make it among, we can do it between two different algorithms, or we can have one suite of algorithm like Hayes ABR and low latency, ABR. So these are like ongoing analysis which I'm doing. And I will basically this work is I just want to clear it. It is segment. I do this. I generated the streaming scenarios using segment based streaming. So now we have like a few different directions, and I already deployed a data set which is not traditional segment based like sequences. Or I deployed one technique which is CMAP, and we further divide the segment, like 2-second segment, into different chunks. We can have like 1 second chunk or 0.5 second chunk. So this is a different technique. So I already built one data set now. So this is the direction which I already started in the testing in real world derived network profiles. So not to be simulated version. I want to get it like and deploy that in real world network profile. And we need to carry out some tests in real latency, ultra latency scenarios. And then we see how does it affect QE. Because as I mentioned, the latency is like it will be measurable with this CMAP chunk mechanism, which is like a little bit like under discussion that how the segment impact the low latency streaming. So I need to created some tests to a varying latency target, lowering latency and higher latency in specific scenarios now in the standardized way. And I need to see like how does it affect the user experience. And then how we different ABR algorithm and dash charge perform under varying latency targets. So that is one work ongoing. And I need to find the optimal latency target, which is dynamically selected based on a client network and device capability. So this is basically dedicated to very like low latency LLL or ultra latency scenarios, chunk-based streaming. And I will conclude my work. Basically, I assess in this piece of part of my work, I assess the impact of ABR algorithms, classical Hayes algorithms, traditional, and with the low latency, and tested that on this segment based streaming scenarios. And I measure the impact of ABR algorithm on the quality switching and DASH. We also build a data set, which is like another in this video streaming domain. And we will build model based on QE metrics and network profiles. measuring and the end user quality of experience. And that's all I tried to explain. If you have any question, any suggestion, make it short so you can, I'm here to answer you. Thank you.
Thank you. Okay, questions for our presenter? Syed, I have a few questions, but I believe that because of time constraints, I'll send them to you privately. Okay.
Right, sir. Right, sir. Right.
Thank you. Maria, I think we can move to the next presentation.
Yeah, so the next presenter is Tomasz Konazinski. I hope I pronounce it decently. And he's going to present on human and contextual bias in quality of experience. So if you can please stop sharing,
Syed, yeah. Please stop sharing so our next presenter can take over. Thank you.
Right, thank you very much. Share my screen.
Yeah, we can see your screen now.
Okay, thank you very much. Once again, hello to everyone. I would like to tell something about a quite provocative aspect, as I have included in the title of my presentation. Because at the margin of my main research concerning the memory aspects, the motivation aspect on the subjective assessment, I hope I will be able to show something about it during the next VQEG meeting. I have indicated that the aspect of psychophysical condition of the testers is quite important factor for eligibility and the results of subjective assessments. These results were quite interesting, and I have made a decision to show you the short presentation about this aspect. Sorry. The research question that arose concerns can declared that psychophysical condition of the tester of subject can affect eligibility of obtained results and subjective assessments, the results of qualified subjects. Many research concerns the impact of the experiment itself, the procedures on the psychophysical aspect of subject, and I have intended to concentrate on the initial status, initial condition of the tester that starts at the beginning of an experiment. How the declared condition, how it impacts on the gathered results. Why is it important? Probably you would say we have mechanisms to eliminate the outliers, etc. But we have quite frequent situation that we must run some experiment. We must run the research with a limited budget and implying the low availability of the testers. If we don't have money for research, we don't have testers. We don't have results as an aspect, as the final aspect and implication. The aspect of psychophysical condition is probably important from the point of view of the resources that we can arrange, because if we have people who are not concentrated on the experiment, we waste our money, we waste our time, we waste our resources. As I said, this sub-research, let's say, was on the margin of my main research path, but I have decided to look at the two aspects of psychophysical condition. They are the level of tiredness and the experienced mood. As it was not a research that was fully concentrated on these aspects, I didn't make any psychological mechanisms to identify independently identify the condition. I have based my research on the declarations. The tester has declared its or his or her level of tiredness and the mood, with the assumption that the high tiredness or negative mood qualifies the tester to the tester with bad psychophysical condition. One of these conditions should be present. In case of a low, medium tiredness and positive neutral mood, it was the state of good psychophysical condition. Regular experiment, as many of experiments that were discussed during this meeting and previous meetings, regular experiment in accordance with P913 recommendation, movies, videos on 5 levels of degradation based on VMAF 61 testers that were divided into 2 groups. I have made this experiment for 2 groups to look at the repeatability of the results, to look how in these groups people behave. This is the structure of the experiment. Testers had a questionnaire to fulfill, a questionnaire concerning, among others, the declared psychophysical aspects, the system mood and tiredness. Videos that were presented and of course assessed. Looking at the eligibility of the results, what I get in this experiment. I received the results as you can see on this graph. Depending on the psychophysical condition, the percentage of qualifications of the testers is significantly differing. For good psychophysical condition, we have a percentage of acceptance on the level of 78.5%. Quite good result. For neutral psychophysical condition, it's a little bit lower. For bad, it's lower. For very bad, I mean, very bad means the declaration of both high tiredness and bad mood, negative mood. The qualification percentage is 0. None of the results, none of the testers, none of the subjects was qualified in the outliers elimination procedure. Looking at the graphical illustration, it is visible that the worse declared psychophysical condition, the bigger percentage of rejected subjects. It means, in fact, that if we don't verify the psychophysical condition of the testers, we waste the money, we waste the time for people whose results will not be qualified. So the correlation between the declared psychophysical condition and the eligibility of the results was proven in some way with the use of the outliers elimination procedure. Looking at the subjective assessment, when we qualify the people, we have a pool of testers that will be valid for this experiment. My hypothesis was that the declared bad condition, psychophysical condition of the tester impacts the subjective assessment. How? As it was presented on this graphs, the orange dots are the results, most results of the people with declared bad psychophysical condition. The blue ones are for people who self-identified as people in good condition. For both independent groups, the phenomenon was similar. The results, most results of the people with bad declared condition are higher. Why? In fact, for the time being, I don't know, because in the statistical analysis, I didn't prove that the statistical significance, probably because of the high percentage of rejections. These groups were specified after the rejection, outliers rejection procedure. There were in significantly different size, because much more testers out of the bad condition group were rejected. So the conclusion in this case is much weaker from my side, because we can see some difference in the assessments. The people with bad psychophysical condition assess videos higher, more positively, but the statistics do not confirm that. So probably, as it was my first approach to this aspect, probably I will look at this phenomenon more deeply in the further course of my research. But as this dependencies are common for all groups of videos, all groups of testers, coming back to my topic of this presentation, you and us, QOE researchers, should restrict access for testers in bad psychophysical condition from the perspective of research with limitations in terms of budget and resources availability. Probably the answer for this question is positive. Probably we should verify the psychophysical condition of the testers before starting research. But of course, it is not very practical for implementation, because it would make experiments much more complicated if we had to do it. And that was what I intended to show you. I know that this is not probably the area that is very important in case of new horizons, but probably this aspect of the psychophysical condition should be mentioned and should be in our minds when we run any experiment in a subjective assessment. Thank you very much, and I stay at your disposal for questions.
Thank you, Thomas. Actually, before we open up, I beg to differ. In my opinion, this contribution is very important, both from the research, of course, angle and in practical terms. So I'm very happy for your work. Any questions for Thomas? So I understand that there is this like dilemma, right? Do you really want to capture the opinion of, I'll use a generic term, rather than bad psychophysical, I would say unhappy, okay, I'll use a shortcut. Should we really have unhappy people participate in a subjective test? Your results point to two different directions to me. Maybe we shouldn't, because there is enough error, or higher error is how I would interpret, right? But at the end of the day, regardless of what you're testing in the lab, there is plenty of unhappy people in the world that will be watching video. Wouldn't you like to know how they perceive quality? So I would say it's an ethical dilemma at some point, but we have to accept reality. So I find it very challenging where to draw the line. So on one hand, you don't want to do that because you don't want, first of all, to introduce much error in your measurement, but you may be asked to do that. And I see Maria raising her hand.
Yes, a quick question, since I see we don't have much time, but my question is on the practical aspects, because I found your presentation very interesting and reflecting on how we can implement it in practice. So of course, what you presented is self-reporting, right? So subjects self-report their status. My concern is that if we ask them to self-report and they understand that they will not be paid because they would not do the test if they self-report a bad condition. Maybe they would not self-report it. So it would be interested in this case to do a quick test, which is not self-reporting for that. Do you have something in mind in case that we could use?
In fact, this is one of my future directions, to find a tool, a practical tool that could verify this condition. I definitely agree that it is not practical. I have shown it on the slide. This is not practical to ask people every time with the conscience that their answer that they are in negative condition would eliminate them from payment. So this is absolutely not practical. Probably it would be useful rather in let's say voluntarily based research. I think perhaps it would be useful, and probably some kind of tool that would assess the real condition of the tester could provide some kind of how to say, some kind of some kind of information that would eliminate this bias, that probably some value could be added to the results. For example, if we have that, if that would be proven in the next experiments that this psychophysical condition really matters and really introduces some kind of bias for the research results. But I don't have a ready answer about the practical methods. I'm thinking about it.
Yeah, thank you. Because there are some sensors that can be attached to the subject to assess the status, but of course this is also taking time. But it was a very interesting presentation, so it may lead to further discussions and thinking around it. So thank you for it.
Thank you very much.
And we have Dietmar who has a question.
Yes, thank you very much for the presentation. And I think if I understood correctly, one of the problems was for the second hypothesis that you had discarded a large number of participants that declared a psychophysical condition, a bad one, as outliers, and then you couldn't tell for sure what the effect of the condition was on the resulting reconstructions. But how about applying one of the statistical models that would assess a bias for everyone, for all the participants, like Surreal. Surreal is estimating an additive bias and also is estimating inconsistency or just the variance of the ratings. So I could imagine that if someone is in a bad mood or a bad psychological condition, then the ratings could have either effect, a negative bias, maybe scoring, everything is bad quality because of the bad mood, or not seeing the value of a good quality, or just by not being really attentive to the experiment and scoring more or less randomly. And but with this tool of these statistical models, you could look at all the data that you have and analyze the bias and the inconsistency and see if they differ between the two subgroups that you have, those that declared the condition and those that did not. That was a suggestion, or maybe you've tried it and you could report it already. I don't know.
Yes, it's great suggestion. Definitely, I think I should follow it because probably it would be the most efficient way to manage this this aspect. Probably better than finding psychological tools for digging this gap. So thank you very much for this suggestion.
Thank you, Dietmar. I was about to suggest the same, so you beat me to it. And unless there is anything else, let's all thank Thomas again. And Maria, let's go to the last presentation.
Yes, so the next presentation is
Thank you very much.
Again on human factors for subjective testing, on crowdsourcing in particular. And the presenter is VQEG Dutta, and online.
Yes. Am I audible?
Yes, not loud, however.
Okay.
I just want to say, it's okay, I believe, if the group agrees, unless someone is super hungry, given that the lines will be diminishing the more we delay. Maybe take your time. I mean, I know we shouldn't stick to the 12:15, I think, break. What do you say, Sal? All right. So it's okay to go over a few, like 10, 15 minutes more.
Give me a moment for the screen.
And really, try to bring your microphone a little bit closer to your mouth.
Okay.
I don't know. I don't know where is the microphone, to be honest. Sometimes it's on the headphones.
Is this visible, my screen?
Your screen is not visible.
Not yet. No.
Okay, give me a moment.
Digital twin.
And screen.
Cannot see it yet.
No, not yet. Do you mind if you're having technical trouble? You can send it to maybe Maria to just flash the presentation, and while you're speaking over it.
It will be nice. Yes.
Have you sent it already?
I'm sending.
Yeah, please do that.
Do you have my mail, Avreggioti? So m.martini.
I am sending here in this chat.
Okay.
Yes. Can you receive it?
Okay. Yes. Okay. Let me share it. It's a Google one, and let me see how to.
Yes, it was in Google
Yes,
Doc.
I'm just trying to place it in presentation. Okay, slideshow, it's here. Okay. So let me first share and then place it in slideshow. Sorry, give me a second. I cannot find the window, the right window to share. Here it is.
Yes, actually, it was problem with me also same.
Okay, it's fine. And now let me place it in slideshow.
Yes.
You should be able to see it now.
Yes.
Perfect. Please go ahead.
Yeah. Thank you, Maria. Yeah. First of all, I wish you all of you the very good morning, and to my colleagues, and thank you for giving me this opportunity to VQEG members also. I am Abhrajyoti Dutta, a PhD student of Information and Communication Technology from AGH University of Krakow, Poland. My supervisor is Dr. Mikołaj Leszczuk, and co-supervisor is Dr. David Juska. Today I am going to present my extended research work. The topic is human factors influencing on crowdsourcing subjective video quality assessment. All we know that the human factors, that means the characteristics or behavior of participants that can affect how they judge the video quality, and this includes things like attention span, fatigue, cultural background, age, gender, and the vision. And we all of know that the crowdsourcing means collecting data or opinions from the larger group of people from online, often from diverse backgrounds, rather than in a controlled lab. And the last thing is subjective video quality assessment. As we all of know that the participants watch videos and rate how good or bad they think the video quality is based on their personal experiences. The next slide, please. The problem statement, this research aims to explore the impact of network factors on user perceived video quality by utilizing ecologically relevant assessment standards that closely mimic real world scenarios. The study will help in designing more reliable evaluation framework for video streaming and conferencing applications, ultimately leading to improved service optimization and user satisfaction. Next slide, please. This is a group project, and why I am concerned with only the crowdsource platform. The study likely aims to understand how network performance affects users' viewing experiences, whether existing quality assessment standards accurately reflect real-world expectations. As I mentioned, research could be explored the use of more scenarios and the evaluation of the summaries by end users to assess their usability and the effectiveness. The selection of the approach for evaluating subjective quality is contingent upon different human influence factor, that means age, gender, educational qualification, etc., and warrants meticulous consideration to guarantee the accuracy and the consistency of the outcomes. Now, this work includes exploring different segmentation and the guarantee to accuracy to consistency of the outcomes. Now, this work includes exploring different segmentation and the selection methods and evaluating the proposed technique, the larger data sets. The rise of introduction, the rise of online video material in the digital era has increased the demand for efficient quality assessment methods. The use of crowdsourcing evaluation has emerged as a potential method of assessing user opinions on video quality. This strategy leverages the collective wisdom, the online communities, to acquire a wide range of feedback. Processed video sequences, that means PVSs, and the user-generated content, that means UGC, are important part of the current multimedia environment. Both type of content present distinct difficulties when it comes to assessing their quality. Moving on to the main body of the presentation. Next, please. The scientific experiment. In this research, we present a crowdsourcing experiment for a determination of the quality of video clips. The experiment aimed to evaluate the effectiveness of crowdsourcing platforms to investigate the impact of different influence factors in the quality of videos. We use an online crowdsourcing platform such as a website actually made by our programming languages that like PHP, JavaScript, and CSS to recruit participants for this experiment. The individuals were provided with a set of guidelines based on the ITUT P910 guidelines, step-by-step guides provided there, and sequential instructions for users to follow, enabling them to complete a task without requiring additional video or text explanations. ITUT P910 subjective video quality assessment methods provides a standard framework for conducting subjective video quality assessment, focusing on the evaluation of video transmission services. We used that methodology, the single stimulus continuous quality evaluation, which is subjective video quality assessment method that requires viewers to continuously rate the quality of video presentation as they watch it and providing a real-time assessment of the video's quality. Next slide, please. The user information, where the age is a key demographic factor in a video quality assessment, and as individuals of different ages may have distinct perceptions and preferences while evaluating the video content. The another one is gender, is another demographic characteristics that captures an individual's self-identified gender identity, which can have unique implications for video quality perception compared to other demographic factors. The geographic location refers to the physical place or region where the upper participating in the video quality assessment is located, which can provide additional contextual information beyond just age and gender and the others. The next slide, please. The crowdsourcing. The crowdsourcing is a technique that involves dividing a task into smaller parts and assigning them to multiple individuals for completions. The collective intelligence of a group can be harnessed to perform tasks that are excessively difficult or beyond the capabilities of machines operating independently. The use of crowdsourcing for the assessment of video quality has significant potential for future advantages. The crowdsourcing provides a comprehensive, diverse perspectives on video material, resulting in summaries that more accurately reflect the preferences and the needs of a wide range customers. The next, please. The flowchart. The study investigates the evaluation of subjective video quality utilizing short video clips on a crowdsourcing platform. The study emphasizes the significance of considering the contextual variables and the network factors such as internet speed and the monitor resolution and the experimental design when evaluating the video quality. The findings improve our understanding of how users perceive video quality and provide valuable insights for future research on multimedia technology. Participants were explicitly advised to refrain from engaging with the videos during playing, such as pausing and right-clicking following completion of each video clip. A voting page would be displayed for evaluation purposes. After completion, the participant received a message confirming their successful participation. Next slide, please. The experiment was conducted using a customized website that was created utilizing programming languages, as I mentioned, the PHP, HTML5, and JavaScript. This website allowed for the assessment of subjective video quality. A total of 47 engineering undergraduate students participated in providing ratings for 170 short video clips using the absolute category rating scale. Participants utilized the platform by assessing it through LAN-connected laboratory computers. The experiment includes a selection of 170 short video clips taken from various databases such as Netflix, Cable Labs, and SJTU Media Lab, and etc. All videos were the full HD resolution, specifically 1080 and to 1920 pixels. The experiment procedure involved the random presentation of video clips to participants with duration ranging from 9 to 21 seconds. The experiment was carried out solely on the Google Chrome browsers on incognito mode to guarantee uniformity to eliminate extraneous interference. The experiment was completed in a total duration of approximately 55 minutes. Next slide, please. I did this experiment with our previous colleagues, with Thomas from our research group, and he gave me the videos, and we created this crowdsourcing environment. Next slide, please. The voting page statistical analysis was conducted to compare decision times in various video category quality ratings. That means response times were calculated and compared for each quality level. After seeing each clip, the participants evaluated its quality using absolute category rating scale, which includes categories such as excellent, good, fair, poor, bad. Participant assessments were recorded in conjunction with response times, which were quantified in milliseconds. Next slide, please.
Sorry, it doesn't move. Give me just, it doesn't go ahead.
Okay.
Is it here?
Yes.
Okay, maybe it was a matter of time.
The table illustrates the average response times for each quality level, highlighting the much longer response times reported for videos of fair quality. That means 1867.19 milliseconds. And the table displays descriptive statistics such as average values, the variability represented by standard deviations for reaction times in various quality categories. The considerably longer response durations found for fair quality videos suggest that the participants took more time to carefully consider their assessment, potentially indicating a greater level of cognitive processing and the evaluative effort. This phenomenon necessitates additional exploration of cognitive mechanisms that underlie subjective quality evaluations and its implications for the designs of evaluation of multimedia material. The histogram of participants' response time of votes for different ACR video quality level mentioned in table, and it is visible that fair quality has taken much more time from the others. And most of the participants successfully completed their quality of assessments within the designated threshold of 5000 milliseconds, that means 5 seconds, within the 5 seconds, suggesting effective decision making process and active participation in the activity. This discovery indicates that the participants were capable of making quick assessments of video quality even when brief video clips were shown. The statistical analysis and validation, the statistical fitting applied to measurement results for better significance. Gaussian distribution was initially tested but showed poor fitting at larger response times, and gamma distribution provided a better fit, aligning more closely with sample mean and the standard deviation. That means the response time data follows the gamma distribution for different video quality cases. The reliability of quality ratings confirmed through internal consistency and inter-rater agreement tests. The conclusion is higher cognitive effort needed for fair quality videos and impacting the user experience. The statistical insights emphasize the role of cognitive processing in subjective video quality evaluation. Next slide, please. The conclusion: the study analyzed subjective video quality assessment using crowdsourced evaluation, the absolute category rating scale, and the result shows that the videos of fair quality required longer response time, indicating increased cognitive effort in evaluating the moderate quality content. Experimental design followed ITUT P910 guidelines using the Google Chrome in incognito mode and the automated playback to ensure reliable and the unbiased assessments. Findings have practical applications for content creators and platform developers and the quality control professionals to optimize the video compression and the streaming strategies. The response times serve as the insightful cognitive parameter, providing additional context beyond the conventional quality ratings. The crowdsourcing proves to be a scalable and a reliable method for subjective video quality research and facilitating the efficient data collection. The next slide, please. These are the references I used. I am fortunate. I used all of these references. And the next slide, please. Until now, I published these research papers. I have few papers to submit this year. And thank you very much for your kind attention. I will be very happy to any questions and comments from you. Thanks all.
Thank you, Avrajyoti. Opening up for questions online, in the room. I see Sel.
Yeah, thank you for a nice presentation. Could you go back to the slide where you showed the different response time? The one back more, I think. here. What would be the error bars or confidence intervals on those bars in this left graph?
Left graph, that is the
okay, I see it there,
milliseconds,
but
yes, and the excellent, good, fair ACR level.
I mean, can you translate it to like a 3 sigma kind? Even if you do a Gaussian fit, right? We would like to know the like 95% confidence interval based on your standard deviation.
Yeah, something like that. Yes, thank you.
Do you have like the error bars that go up and down?
I mean, it would be interesting to see whether at least illustrate. I cannot translate the standard deviation there directly to whether these differences in the height of the bars are actually statistically significant or not. So, could you tell us whether you checked if the differences are statistically significant between the height of the bars?
Yes, actually, I I collected from the data sets, and our result, I put it on the Mathematica software and put it there. I saw that the gamma distributions are very much fitted with that. That's why.
Yeah, I think the suggestion is you can take these, again, in first sight, it seems like a standard deviation of 870 on a value of 1,512 imposes a high error bar. So that number is uncertain, right? It is the mean, but it has a very high variance.
Yes, yes.
Is how I would read it. So if you do a statistical test, it will show you is the difference you're seeing statistically significant or not. And that is really, I think, the ask and the suggestion from Cell. Yes. So you may want to add that information. And if it is not statistically significant, it may mean you need to get more crowdsourced workers, ideally to reduce that so that it becomes tighter, would be my follow-up.
Yeah, I mean, otherwise it could just be a difference made by chance.
Yeah, it could be just a random phenomenon, right? If it is not really statistically significant. Okay, any other question or comment? Hearing none, back to maybe Maria to wrap us up, I think. Maria?
Thank you. Thank you, everyone. No need to major wrap up. I know you have lunch. So maybe just a reminder to contact Nikolai and myself if you're interested in being involved in the activities of the group. And also if you have a specific problem you would like the group to address. Thank you, everyone.
Thanks, Maria. Thank you for staying up late, all the presenters who presented remote. So let's stop the recording.